Hey everybody. Hey Jared. Jared, can you hear me? Alrighty. Hey everybody that is hopping in. We're gonna give it a couple minutes for everyone else to kind of trickle in, and then we will get started. Can everybody hear me okay? Awesome. Sweet. Thanks everybody. Yeah, we'll just give it like I said, a couple minutes. We'll let everybody kind of trickle in, and then we will kick off.
What is going on, everybody?
Hey, I was just saying we'll give it about probably 2 more minutes or so, and then kick off.
Hey, Tyler, you should refresh your screen real quick.
All right. Well, that's enough time to wait. I don't want to keep waiting for forever. And when we're sitting here just waiting, the seconds feel like a lifetime. So let's just go ahead and get started. So, hi, everybody. Welcome to the Weaponizing Sigma workshop. Thanks, everybody, for hopping on. Yeah, hopefully this should be a good one. So, up first, I guess just who am I? Hey, everybody. I am Tyler Casey. I'm the lead detection engineer over here at Scythe and SCYTHE Labs. Have about a decade or so of defensive cyber operations experience, DCO experience. Currently, I run the blue or the defensive side of our purple team engagements, and I'm responsible for a lot of the tests and the threat emulations that we put out, and then the subsequent detections written in Sigma that come out with each of those tests and threats. Before I came over to Scythe, I was on a CPT, which is a cyber protection team, where we deployed internationally for targeted incident response and threat hunting. I'm in the St. Louis area. I got my socials down there. If anybody wants to connect, I would love to chat.
Hey, y'all, I am Trey. I'm the head over here at SCYTHE Labs. 17 plus years in IT and cyber. I've done a ton of roles. You can see them all down there. I have alphabet soup if you care for that kind of a thing. Check out my LinkedIn. Socials are at the bottom. I'm down in Florida if anyone actually cares and wants to come hang out and do stuff. We do cool things down here.
And then we have Jared as well. I didn't put your slide in here. I'm sorry, sir. I don't know if you want to just say hello real quick.
Yeah, hey, I'm Jared. I'm the newest member of the SCYTHE Labs team here, and I'll be doing the TAing today for everybody. So if you've got issues or got questions, I'll be able to help you out.
For sure. Thank you, Jared. So yeah, with that, if you have any questions or problems or anything at any time, please just throw it in the chat or in the Q&A or message Jared directly, and we will get you sorted. So this is a mostly hands-on lab-based workshop. Ideally we'll only have to talk for like 30, maybe 40 minutes or so. So it should be, like I said, mostly lab based. You should have, if you signed up, you should have gotten an email from CourseDeck. That's our lab environment, or the provider of our lab environment. Should have gone to whatever email you signed up for. If you did not get this email, please let us know now. It takes a little bit for the lab to spin up. So please let us know if you didn't get this email. If you did, please go ahead and click on it and start your lab. It should look, when you click on it, you might get a page like this because you might have just clicked on it a minute too early or something. But if you refresh, it should bring you to this page, which is our workshop page with our manual and everything. And then once you're logged in, go ahead and click Launch Group. What that's going to do is actually launch the web, or excuse me, it's going to launch the all of these images, all these systems we have over here at the side. Like I said, it takes a few minutes for it to spin up and for DNS and everything else to connect. So you want to go ahead and start that now. So when we get to it, there aren't any issues. And then again, if you did not get this email or it doesn't work or anything, please let us know as soon as you find out so we can just handle it now.
Say if you did not receive the invite email, go ahead and drop your email address of choice into a message to us,
Yes.
and we will get you set up.
Alrighty. And then, yeah, again, once you are in there, please just launch the group now because it'll take a little bit. We've had a little bit of issues with the boot order of things, so we want to give it as much time as possible to stand up. So over to what we're actually going to be talking about today. So today we're going to be talking about Sigma, right? Obviously, that's the name of the workshop. That's what we're here for. So we talk about Sigma, why we care about it, why it's important, why I like it so much. We're going to go over how to create a standard rule, how to find some different rules, how to translate that rule into something actionable, into a query of some sort. And then we're going to execute some adversary emulations on our side. Let me just close out of that. We're going to run some adversary emulations through Scythe in the lab environment, so that way we have some logs that populate, so we can prove that our Sigma rules work. We can see some detections and see if they work. Again, mostly lab based. I'm going to try to kind of quickly go over the slides because I think that Sigma, like a lot of things kind of in DCO or detection engineering, is really something you need to just get your hands on and start doing, right? Going over the slides is great, but really getting into the manual in the workshop is I think a lot better use of our time. So with that, while we are going over the slides, if you do have any questions, comments, anything you want to throw in, please feel free to do so. Toss it in the chat. If you want to talk, I can promote you up here so you can chat with the rest of us. Yeah, let's try to make this as interactive as possible, right? And then again, the last time I'll say it for at least a few minutes, if you don't have the CourseDeck link, please let us know because it's a real pain trying to do it later. It's much easier to just do it now while I'm kind of talking. All right. So with that, I guess before we get started, does anyone have some experience with Sigma? Utilized it in your work, or just kind of familiar with it, heard about it, anything like that? This, if not, don't be concerned at all. This is really kind of an intro, and then we'll get into more of an intermediate type stuff. But if you don't have any experience with it, don't worry. We're going to kind of cover it from the beginning. Okay, Michael Bauer uses it daily. Never had hands-on experience, but heard about it. Okay, cool. Yeah, one of the reasons that we wanted to make this workshop was because I think a lot of people have heard about Sigma and never really got a chance to operationalize it or use it in it's in a true functioning kind of way. So I think that this workshop should be a great way to kind of get everybody started. But with that, let's hop into it. So Sigma, what is Sigma? Sigma is an open source structured format utilized for writing detections. And this format is going to be written in YAML, right? So Sigma HQ, which is the creator of Sigma, as far as I know, Sigma HQ, they house thousands of different community detections for us to utilize and also contribute in their GitHub repo. And then in this workshop, basically what we're going to do is what we have in this infographic here. We're going to take a Sigma rule, we're going to convert it, we're going to deploy it to our SIEM, and then test and see if we get any detections back. And then I guess one other piece of this before I move on, you notice the image on the image all the way to the right, it has all of the different all the different EDR vendors and SIEM vendors and things like that in there. Really, the main benefit of Sigma is that you can translate just that standard kind of rule written in YAML and convert it to really any kind of security tooling that has some kind of a query bar, right? Whether that's Splunk, which is what we'll be using in the lab, or Kibana, Elastic, Rapid7, CrowdStrike, Sentinel, etc. So no matter what EDR or SIEM that you guys utilize in your environment, you'll be able to take really any of these rules that we make or that we procure or find or anything like that and translate it to fit your environment. So I guess a little backstory before we get into the more technical piece is kind of, again, why this workshop exists and why we're talking about it, why I like Sigma so much. In my experience of doing DCO and some different defensive operations, detection sharing is not super great, right? A lot of detections are written by analysts in a silo, kind of on their own at their desk with a little bit of collaboration. And more often than not, people don't want to share what they've made, right? Either they're nervous about it or they don't think it's very good or whatever it is. So a lot of times that those rules, those detections that they make just kind of stay on their notepad, on their desktop, on their own, and they don't really share it out with anybody or do anything like that. And it that I've been on missions where we've been out there threat hunting, looking for the adversary. I'm seeing different analysts run queries, write rules, write different pieces like that. Get results back, get good information back, and don't share it with anybody, even their own internal team, right? And so you have to kind of claw at them and get at them to try to share it in a way that everybody can kind of see it. If they write it a little weird or it's not in some standard format, it can be difficult to share it kind of initially anyway, right? So detection sharing kind of as I saw it was just not super great even with an internal team, right? And then another way is of some kind of pitfalls of detection sharing that I'd seen is a lot of detections or queries that people write are tool specific to their tool, right? Which totally makes sense because if you are writing a detection, if you use Splunk or whatever, you're going to write your detection rule in Splunk because that's what you're utilizing in pieces like that. And all that is fine. And it was fine for me when I was doing it like that until we started doing some incident response or some purple team engagements.
Sorry about that. I think we might have lost Tyler as a whole. Let's give him 1 second. Yeah, I don't think he's muted. I think he just straight up fell out. 1 minute. Sorry about that. Yeah, sorry. I guess now's a good time to stretch your legs. His computer decided to do the good old reboot on him with no choice. So 1 minute. Uh, While we're waiting for Tyler to drop back in, I know quite a few of you just joined. Has anyone sitting in here currently not gotten the invite link to Core Stack? Okay, if you guys could drop a message to host and panelists with your email address, and we will get you added into the lab environment so you can get that spun up. Okay, everybody. He is still restarting. So I think what we're going to do in the meantime is take a few minutes to familiarize ourselves with Core Stack and navigating around the platform and going through the first section. So what we're going to be looking to do in here, as you get into Core Stack, after you've launched your systems from here, come up here to chapters. We're going to go through this first initial introduction. So what this is going to have is any particular information that you need to work in the lab, has some useful links. This next page is just a quick familiarization video. It's about 6 minutes long. All it does really is kind of tell you where all the different pieces and parts are in Core Stack and how to navigate around in the lab environment. And then these last three, you can think of these as like cheat sheets for the Scythe platform for Sigma and Splunk, as we'll be using all three of these today. So what I would say is let's take a quick, let's say six to 10-ish minutes. What's 118? So we'll say by 1:30, let's have everybody go through these couple sections and watch that quick video, make sure they're good with Core Stack. By then, we should have our fearless leader for this session, Tyler, back, and we can get rolling again. Anybody have any questions there? So again, we'll be doing the welcome page to Splunk familiarization. There's not much for you to do in there. It's more just like quick look over of the guides and the Core Stack video itself. Let us know if you have any questions. We should have our Tyler back here in the next few minutes or so. Yes, you should have gotten an email invite for no reply at Core Stack. That will give you access to the lab environment. If you don't have that, just send me a message in Host and Panelist and I'll get you added so you can hop in and access it. All right, there he is. Fearless Leader is back. Again, while everybody else is going through that first section, Rommel, can you send me your email? We'll get you added to the lab environment.
Trey, can you hear me?
I can.
Okay. Sorry about that, everybody. My computer just decided to turn off out of nowhere. Sorry about that. Give me one second to reshare.
So just as a heads up, I went ahead and had them go through the introduction chapter, so they were being productive while you were
Okay.
troubleshooting.
Awesome. Yeah, thanks. Yeah, sorry, everybody. I'm not sure what just happened. Uh, that's what you get for doing it live. Do I sound okay in the headphones? Now they won't connect via Bluetooth, so I'm just plugged in directly.
Yeah, perfectly fine.
Okay. Uh, one second. Do you put a timeline on the
I told
lab or
them by
just hop back in?
13:30 Eastern at the latest, so like
Okay.
another 5 minutes.
Okay. Yeah, we'll
But
do another.
most of them are probably already through it though.
Okay. Sounds good. Well, then I think I'll probably just pick up where we left off. Um, Second for it to share. Okay. Yeah. Okay. I'm not sure where I cut off at when I was talking. Um, so again, really sorry, everybody. I'm not sure what happened with my Windows machine. It just decided to stop working. So, but I'm back hopefully for the rest of the time. We'll see. But back on the detection sharing, kind of what it was, right? The gist of it, it was bad, right? People don't want to share rules. They don't want to write it in a standard format. Um, or if it is written, it's written as a query, excuse me. It's written as a query in the tool that you already use, and if you go somewhere else, right, it doesn't really translate exactly. Utilizing Sigma, you can translate the rules in all one standard format, share them out with everybody, and it's just a lot better, right? It's what detection sharing, what detection engineering, what it should be, right? Having a centralized repository written in a standard format that's tool agnostic really does make up for a lot of those shortfalls that I pointed out either a minute ago or 10 minutes ago, right? Depending on when my computer turned off. And that's, again, what Sigma brings to the table and why I enjoy talking about it so much and why I use it all the time, right? Every day. Can't say enough good things about Sigma. So Sigma HQ's GitHub is more or less the centralized repository for all of the currently published Sigma rules. We're going to get into the Sigma HQ repo here in a little bit. You could also just Google it, Sigma HQ GitHub, and start kind of fiddling around with the different rules that they have in there. But it's a great start in kind of your detection journey, right? They have a bunch of already pre-published rules. You can go in there, you can start to use them immediately. If you have some rules that you've created, you can do a pull request, you can push your rules up to them to get them published, and that way everybody can kind of use them. And again, on the standard format, it's really important to have a standardized format everybody can write in. Um, a huge benefit of that is that anybody in this workshop, whether we've ever met before, whether you know me, whether I've worked with you in the past, you can take a rule that I've written or anybody has written and translate it to your environment, and we're going to get the exact same results without needing any other kind of context, right? You can just pull the result, or excuse me, pull the rule, translate it, and then you're off and running, right? You don't need any kind of back info or anything like that. You can just kind of go. And then again, like we pointed out, you're able to translate your Sigma query into pretty much any security tool that has a query bar, right? Whether that's EDM or a SIEM or a SOAR, there's all kinds of different applications out there now. But you can utilize tools like Uncoder, SIG Converter, or the Sigma
CLI. Those last two we'll be using in the workshop to translate our rules, um, to translate your rules into whatever tool that you're using. Everybody takes notes and writes their queries a little differently, but if you employ this kind of standard format that's stored in a centralized repo where people that need to get to it can get to it, it can be automatically translated to pretty much any query language. You're really kind of enabled your security team, enabled your defenders to write better detections faster and share them so more people can use them, right? You don't have to reinvent the wheel. You don't have to write detections that are already made, or anything like that. Point out, the last little bit of my soapbox that I have up here is that probably everybody in this in this call, everybody in this workshop is a defender of some kind. Even if you work for offense, cyber offense is still a defensive action. It's a defensive function. So we're all, the point of it being, we're all in the same fight, right? We all want the same thing. We all want to find the bad guy and keep our environment safe. So by using Sigma, even though it sounds kind of simple and silly, utilizing something like this that everybody can use really does bolster the entire community, and not just your organization. All right, enough of that. Over into Sigma, right? So this is just like a quick little view of what Sigma HQ's GitHub looks like. Again, it's where they host all of their current rules. It's got a little search function at the top, just like GitHub, right? So you could search, you could search for T codes, you can search for 7-zip, you can search for keywords, all kinds of different pieces like that to quickly kind of find and curate your rules. In this snippet that we have, we're looking for detections that are related to 7-zip. Again, you could just kind of search for it right up there at the top. Detection.fyi is another great resource to find Sigma and different detection rules. They don't just have Sigma rules in there. It's a little more user or UI friendly if you don't like the kind of minimalistic feel of GitHub. But just a quick little journey over to there. So Sigma HQ, right? So we're here again. If you want to see 7-zip, here's all the 7-zip rules, right? Can hit enter and not search. But you can do 7-zip up there if you're looking for different CVEs, CVE with whatever number you're looking for, different pieces like that. Very easy to navigate through, very easy to find things. And like I said, they're already tested, tried, and published over here. And then similar on the detection.fyi page, it's got some of the newer ones that are listed out over here on the left, but you can also search, 7-zip, whatever it is. Give it a second. One thing I do like about detection.fyi is that it looks across multiple different repositories. I'm not sure exactly how it gets submitted to detection.fyi, but it looks across multiple different repositories. Oh, it just loaded now that I hit cancel. But a lot of different repos in here. You can go directly to the GitHub page from detection.fyi. Just again, a little more of a user-friendly kind of approach if you don't like the UI feel of GitHub. All right. So now we've kind of talked about the state of detection sharing, detection engineering, kind of as I see fit, my experiences with it, talked a little bit about how Sigma can alleviate some of those rules, where to find them. So now we're going to get into the actual rules itself, how to create them, how to read them, and some different pieces like that. All right. So obviously in this workshop, it's a technical workshop, so we're going to get in the weeds a little bit, or hopefully a lot, into Sigma, and we're going to kind of go back and forth in different pieces of it. So before we get into all of that, we thought it would be good to just kind of show you a rule if you've never seen one before, just to give you a frame of reference and what they look like and kind of what we'll be looking at, right? So this rule that we have here, it's going to detect potential DLL files that are downloaded via the invoke web request commandlet via PowerShell, right? So if you focus in on the detection section itself, that's really where the meat of everything is. That's really where the most important pieces of the rules are in that detection section and the condition it has there at the bottom. But if you look at the detection section, you see that for our detection to hit, it has to contain either invoke web request, IWR in the command line, and the command line must contain HTTP of some sort, out file, and .dll. We're gonna get into exactly what all these fields mean, what the contain means, what that condition means, what's going to make the rule hit. As we get into the workshop, we just wanted to show you this kind of upfront, give you a frame of reference, and hopefully it'll make things click a little bit faster when we get into the weeds of it. Okay, cool. Just checking the comments real quick. So into rules 101. You can't make a rule without indicators, right? You need something to base the rule off of. So in my opinion, there's kind of three main building blocks where you can pull your indicators from. The first of those is CTI, cyber threat intelligence, right? So what you kind of want to do out of CTI to get the indicators is you want to look to gather some actionable intelligence. By actionable intelligence, I mean like command line arguments, registry values that are changed, IP addresses, maybe not a super great detection, but you want pieces like that not strategic level. We want tactical level intelligence that we can write our detections off of. Optimally, it's going to have, like I said, those command line arguments or registry value pieces like we see here, something like that. So in the snippet we have over here, we have a Lockbit ransomware indicators from a CISA advisory. These indicators show that the Lockbit threat actors are enabling automatic administrative logon via the registry keys. So you could create a rule a couple different ways just with this little indicator here. You could create a rule a couple different ways, either with a process creation rule, looking for like these command line arguments or these values inside of the command line arguments. You can make a rule for a registry modification where you're looking at this Windows NT current version when log on to registry key, seeing if any of these values are changed, then getting an alert off of that. You could look just for the auto admin logon being changed to 1. So a couple different rules that you could create just off of this indicator here, even a little more broad if the CTI said that they utilize like PowerShell or something like that to run these commands. Maybe they do like set item or something like that. You could then take a way out to and see if any PowerShell image is modifying the registry as well. So a couple different ways you could take this indicator and turn it into a rule. While we're on CTI, it's a quick little slide about it. While we're on CTI, if you don't know where to find good cyber threat intelligence from, these are the resources that we use, right? This screenshot is of InfoSec Ninja's start.me page. It is a fantastic resource that's got all of these other resources we have on the left are all already built into this RSS feed on the start.me page. Couldn't recommend it enough. Definitely check it out. All right, back to the indicators. The second kind of building block of the indicators is your logs itself, right? Running threat emulations, running tests, or performing purple team engagements are great ways to generate logs that emulate adversarial behavior. If you have what you're hunting for in the logs, it's really the best way to get the highest fidelity on if your log is going to work, right? And this piece of the logs is exactly how we're going to do it in the workshop when we get into the labs in a little bit. We're going to run an adversary emulation, a couple adversary emulations actually, and then utilizing those emulations, we're going to basically work backwards to create our Sigma rules and then prove if they hit, if we're able to detect adversarial behavior with our rules or not. So in this example on the left, we see that our sysmon log has a log entry of PowerShell creating a network connection. This is probably something pretty abnormal in your environment. So you could create a Sigma rule for a network connection being created by PowerShell. You could create a Sigma rule for different kind of internet-facing PowerShell commands like invoke web request or curl or wget, different pieces like that. Different things like that. And then you can go now in your logs, you know that PowerShell reached out to the internet inside of your environment. You wrote a rule for a network connection of the image of PowerShell reaching out to the internet. Then you can translate your rule, throw it in your SIEM, and then see if it hits, which again is what we're going to be doing in our lab. Another kind of good point for this one before we go on is that even if it is common for PowerShell to reach out to the internet in your environment, it should probably only be reaching out to certain sites, right? Reaching out to Microsoft, pull updates maybe. Maybe there's an admin script that runs via PowerShell that reaches out to your WSUS or API keys or something like that, and all that's fine. Or maybe there's like a specific set of users that utilize PowerShell scripts to do something on the internet, and that's totally fine in your environment. Which Sigma rules, you can specify those different kind of false positives at the bottom into saying why this rule might hit, where it might not be bad. And you can also specify via the logic, like you could do if you are going to do the network creation via PowerShell out to the internet, right? You'd have network connection with the image of PowerShell, and then maybe your user Tyler.Casey is the one that's always doing it, and you're like, this is fine. You could then set a value in your Sigma rule for looking for my user count and exclude that from your detection. So you're able to kind of add in or subtract different pieces of your detections inside the rules, which is very valuable. And then the last indicator source that I was going to talk about is your experience, right? Use your experience. If you've been doing this a while, you've been reading things, or you just think about different ways adversaries can perform different actions, you can turn that into a rule. So if you know from your experience that a concerning threat vector is maybe embedded PowerShell inside of a productivity application like Word or PowerPoint or something like that, right? User gets sent a Word document, they open it, it spawns a PowerShell command or script or terminal, whatever it is. You can create a detection off of that, right? You don't have to see it somewhere else. You don't have to read about it somewhere. You can think of different things that you think are valuable, your most likely, most dangerous courses of action an adversary might take, and create a rule on that, and then maybe perform some threat emulation where you do that action in a safe way, and you can prove whether or not your rule is going to hit on it. Again, we're doing something very similar to that in our lab environment here in just a little bit. There any questions so far on anything? Trying to go a little quick through this part because I know that I chewed up like 10 minutes of everybody's time going for my computer to restart. All right. Fantastic. All right. So into the rules itself, kind of out. We're gonna zoom in now from our, kind of 1,000-foot view of Sigma rules, why they're important, and all that kind of stuff. So into the fields itself, Sigma's going to have required fields, right? It's a standard format. It's going to have standard fields that you need to fill out. Some of these are pretty obvious, right? Your title, your ID, your status, all of those, don't really require too much more nuance. It just kind of is what it is in there, right? The main point I would make on this one is that your rules, your status of your rule should be experimental until it's tested, right? It should be experimental probably for months, I think is kind of the standard that they look for there. You don't want to get too ahead of yourself. You want it to be tested, working with the regressions and pieces like that. And then the next point is that you don't want to start your title with the word detects. Make it more of a broad title like 7-zip a file with a password or something like that. And then detects is where you're going to really hit into, or excuse me, the description is going to start with detects and then really get into the description, really provide all of your context. And then a couple more fields. Like I said, some of these are going to require a little more nuance, and they're going to have their own slides. Nothing really super crazy to bring up on here. Just some more rules you have to go in. We'll get into these more when we get into the lab. All right. So some of these, like I said, do have a little more nuance to them. The first one of those is the tags, right? So the most common tags that I see are attack, like MITRE attack, CAR, CVE, and TLP. And this is kind of how they're written inside of the Sigma rules themselves. So up first is MITRE attack, which is the MITRE attack framework. It covers tactics, techniques, and softwares that are utilized by threat actors. MITRE attack refers to threat actors as groups. So it's obviously very robust. I'm sure everybody is probably pretty familiar with it or has heard about it in the past. It is a great way to provide, again, more context into your rules without somebody having to reach out to you. So in this example for attack, we have APT 29, which MITRE categorizes as G0016. That's the group ID. So you can look that up on MITRE as G0016. And they are conducting discovery, which is the tactic, utilizing the remote system discovery, which is the technique, 1018 via Bloodhound, which is the software, S0521. So just with those 4 tags, you know what groups are doing this, you know what tactic they're using, what technique they're using, and what software they're using to run whatever is happening inside of your rule, right? You don't have to use all of these different tags. You can just do, the T codes, the tactics, techniques. But if you can provide more context, it really does provide a lot more value, and people won't have as many questions for you, right? You want to try to answer as many questions as you can up front without having people come back and have some more to ask you. So the next one up is CAR, which is the Cyber Analytic Repository, and I have some links for these I can drop here in a minute. The Cyber Analytic Repository, this is where the pseudocode of a query is, right? So it's going to explain a query in kind of plain English, in the layman's terms. In this example, this analytic tag we have here, number CAR 2021-05005. If you look that up, that analytic tag is telling you that in this CAR, in this analytic story, bits admin is utilized as the process to download a file. In this example, right, let's say that file that they downloaded was Bloodhound, right? So now we can tie this cyber analytic repository report to our software that we pointed out in those attack tags a few minutes ago. The next one is CVE, Common Vulnerability and Exposures. This is a list of all of the vulnerabilities that affect operating systems, software, your fridge, whatever, anything that's got an IP address and is plugged in, right? So in this example, we list out a vulnerability with Bloodhound, right? Kind of tying it all into that initial MITRE attack tag at the top. That allows for execution of operating system commands. So maybe in this scenario, all of the, this is all grouped together. This is all the same rule, right? So in this scenario, threat actor APT29, also known as G0016, exploited this vulnerability to get Bloodhound, also known as S0521, with the MITRE attack tags, to run commands. And that's just kind of an example to group together all of these different tags, again, to tell a story of what is happening. And then the last one is TLP, which is Traffic Light Protocol. This is used to set the disclosure level, right? So red, don't let anybody see it, intended only. Amber, need to know. Green, send it out to the community. And clear, send it out to everybody. So just a way to kind of specify who can see this and who can't see this. A great resource that Sigma has for this is these appendix tags over here. So this breaks down all that I said in way more detail and way more links. It's, again, just a great resource Sigma's provided. Is there a mapping between MITRE attack versus Sigma rule to see what TTPs are covered by the Sigma rule, but TTPs are not yet covered by the Sigma rule? That is a great question. I think maybe the easiest way to show that is if you go into tech.t. There we go. If you go into GitHub itself, into the Sigma rule itself, you can search by T codes 1059. Not there. I want to look for it up here at the top. There we go. So if you search for it up at the top and you just put it in quotes, it'll pull out all of those TTPs and what Sigma rules are mapped to them. So you can see here for persistence 1059 is process execution. So it'll have a lot of these will be tagged with 1059. But if you're looking for something more specific, like maybe 1087, which is system discovery, I believe, you could search by those T codes there and then kind of filter it that way. And then the same for detection.fyi should be able to just look up, whatever the different T codes are that you're looking for, and then they'll populate that way. They also, I believe, on the MITRE attack page that they have some Sigma rules listed out. I'm not 100% sure on that. I'll look when we get into the labs and can share that as an example as well. Oh, and Jared already put those links on there. Thank you, sir. So yeah, again, the tags, just a way to provide some more context so people can know what you're talking about. Yeah. All right, over to standard. So this is going to get into the actual some of the rule writing itself. So the standards of the log source is what is going to tell you kind of the classification of what you're looking for, right? So your product can be either an operating system, an appliance, or a tool, so like Windows or Zeek or AWS, something like that. Your category. I think of these as the action that is occurring, right? So your category can be process creation, it can be a network connection, registry add, registry modification, kind of different pieces like that. It's I think of it as what is happening that I want to see. And then your service could be anything from a literal service like sysmon, or excuse me, like syslog, something like that, or a service that's provided that from AWS like CloudTrail, or some protocol services like DNS, HTTP, pieces like that. Service is probably the least utilized category that I see, or excuse me, the least utilized log source that I see. Most of the time, it's just product and category. Again, these will make a lot more sense when we kind of get into the rules. I know it's probably a lot all at once, but just want to kind of get them all out there. And then I just dropped a link for the Sigma, taxonomy, which breaks these down even further. The last one we're gonna talk about as far as standards go is the file name. This is kind of a soft convention that they have. It really just makes it a lot easier to kind of track everything, keep everything in the standard kind of format. I find that this typically goes category or service underscore the product underscore the action. Again, the easiest way to make sure that you have it right is to just refer to the documentation. And as soon as it lets me copy this link, I will put that in the chat as well. Yeah, easiest way, obviously, refer to the documentation. The more you do it, the more you'll kind of get a hang of it, and it'll all start to make sense. But I would definitely refer to some of these docs. So kind of did the whole background, all these little pieces of the fields, standards, the file name, all that. So let's see it together. Oh, you got a 404. They just updated. Oh, you're getting a 404 for that. We'll look at that here in a second. I'm sorry. I thought there was a 404 on the link. But so, like I said, we went over all the pieces. So now we'll get into the actual full rule itself and kind of break it down. So here is a full Sigma rule that detects 7-zip compressing a file with a password. This rule was written by Frack113. Thank you, sir. So this rule is tagged with the attack T code of T1560.001, which is archive collected data via utility. It's already kind of given us a hint into what it's doing. It's got a description saying why an adversary might do this, why they might have encrypted data prior to exfiltration or something like that. Then we get down to the log source, see that it is a process creation on a Windows machine. So this tells this Sigma rule that it's Windows, that tells it how to kind of format the different parameters over there on the right of like command line arguments or image or different pieces like that. So that's going to look different for a Linux log or a Windows log or a Mac OS log. It also kind of gives us, also lets us know that this log will likely be either in the sysmon or security log because it's a process creation on Windows. That's going to help it translate the rule here in a minute. And then the actual detection piece itself, which again is the most important piece. That's really where kind of the meat of everything is. So inside of the detection piece, we can see that it's looking for matches on 7-zip and command line parameters. Each of these have their own selection filter. Excuse me. And we'll talk about those on the next slide. And then we can see that this rule could also have some false positives, since creating compressed files with a password could be pretty common in your environment, right? Probably not too common because not too many people use command line arguments to make archive files, but in your environment, Jared.Pemberton or something like that, maybe they do it all the time, and it could lead to a false positive. But so for the detection piece itself, like I said, the main part, the most important piece of these rules is the detection piece, right? That's your logic. That's what your query is being based on. So let's kind of get into that and what that means. So in the detection logic, the detection piece itself, we have a couple filters of selection image, selection password, and selection action. So And then our condition at the bottom of that states that we're looking for a match on all of these selections. So what that means is that each of these different selections have to have a hit for our condition to return as true. On the inverse of that, you could also change, you could modify the condition to just say that if selection image and selection password and not selection action hit, then to get an alert. And that's how you get into kind of the filtering of maybe like a username or a computer name or, process location, different pieces like that to add in a little more logic into it. But in this one, all of these conditions have to be met for us to get an alert. So the first one up, the first filter we have is selection image. What that is looking for is that the description, image, or original file name has to be some form of 7-zip, right? It has to fit those exact parameters that we have set over in that purple box. So let's imagine that we get a hit on the image being 7z.exe. Now our selection image is met. So that one's good. So the next one we'll be looking for selection password. What this is looking for is a command line string that contains -p. This is the only condition inside of this filter that has to match. So luckily for us, right, we get a hit on this. Our command line argument has a -p. And then the last filter we have is the selection action, which is looking for a command line string that contains either A or U with spaces on either side. If anybody can tell me why it needs to have spaces on either side, you'll get some bonus of virtual points over here. But so in our example, right, we have our selection action. It has the A with spaces on either side in the command line arguments, and that means that all of our conditions are met, and we will get a return on this value. And then I was hoping someone was going to say why there was spaces on either side. You have to have spaces on either side of the A or the U, because if you don't have spaces on either side, this will hit on anything with the letter A or anything with the letter U on it. So that's why there's spaces on either side, because the contains is essentially going to be a wild card on either side of those. So we have all of our selection conditions are hit. And from there on, we know that this detection rule works and will alert on that specific activity. Here in a couple slides where I'll prove to you exactly how this is going to work. And then a recent-ish update, I think probably in the last 6 months or maybe a year or so, to Sigma is that they've added the ability to create correlated rules. So the rule we just looked at over here is a standard rule, and they added in a correlated rule, which looks a little more like this. So you can see that in our rule now we have these 3 lines over there. That is what is going to tell it that we have a correlated rule. So standard Sigma rules will trigger just on one log source or one event, something like that. There's no way to really add in any kind of additional logic or grouping of any kind into it. And that's where correlation rules come in, where it kind of pushes this a little bit further. And it does that by combining several different events across either time, users, hosts, or log sources to detect attack chains more than just singular atomic events, right? And what I mean by that and why this is better, I think, is really portrayed in this example that we have here. Excuse me. So why is it better? How does it work? If you look on our rule on the left is our standard rule, and the rule on the right is our correlated rule, and how they work together. So the rule on the left is querying the service log for event ID 4625, which is failed logon attempts that don't end in a $sign. A $sign is probably a service account, computer account. We're not concerned with that, right? That's why we're excluding that. What this is going to show you is all failed logon attempts for users, which in and of itself can be valuable. But likely, like if you were to run this detection of just looking at failed logon attempts, you're going to get a billion logs back, right? Or a billion events back, right? Because people have failed logon attempts all the time. If you just run that in, let's say, the span of a day or something like that, maybe even an hour, depending on how large your organization is, if you run that, you're going to get tons of hits back, and nothing is really going to bubble up to the top. So you're gonna have a very difficult time to find adversarial attempts or adversarial behavior by just looking at something kind of as low fidelity as failed logon attempts. Even if an attacker puts in a delay of some sort, like every 30 seconds or something like that, and then people are doing failed logon attempts at the same time, it's just going to fill the log and you're not going to find anything, right? So by adding in this correlation rule we have on the right, it's going to pull out and group the domain and the username. So you'll know like it's looking for that specific user and domain. It's or let me back up a little bit. It's going to run the query on the left, and then on those results, it's then going to filter on the user domain and username. So it'll focus on that one user. It will look inside of a 5-minute time window, right, which you can obviously adjust in your rule to fit whatever your environment needs. And then if it happens more than 10 times, 10 times is the threshold we're trying to hit, right? So now if you run this rule, the anomalous behavior of someone failing multiple times is going to have a lot more context. It's going to be specified to the user, and it's going to make a much higher fidelity alert. Because it's got these additional constraints on it, right? We're looking for if Tyler.Casey has failed a logon 11 times in 5 minutes, that's not normal, right? That's not something a standard user would do. That's most likely, some kind of a brute force attack, or maybe somebody at their keyboard just spamming it, right? But it's something that should be investigated. Where if you don't have that additional context of the time span, of the groupings, of the conditions, you're probably not even going to see it, right? And also too, if you're looking at just failed logon attempts, you're going to get alert fatigue because you're going to get 1,000 alerts, at 8 a.m. every day or whenever you guys start your workday. And you're probably you're probably going to just stop looking at that alert completely, right? Because it has no context, it has no fidelity. There's nothing valuable in it. It's just saying that something happened. So by adding in the correlated searches, you have higher fidelity, faster alerting, and more context, and that's why it's better, right? The last thing I'll say, we're not going to get super into this because it's a little more of an advanced concept for what we're going to be going over in this workshop. We'll do an example of it in our labs. But the last thing I wanted to point out on these is if you notice the name field on the left, which is that second field second field under title, and then you look at the rules value on the right on the correlated rule, they're the same, right? The name is failed logon, and the rules is called failed logon. This is how the rules kind of correlate to each other, right? So those need to match so it knows which correlation that it's going to build that initial standard rule off of. As you get kind of more advanced and start building in detection pipelines and pieces like that, you can have correlated rules match on, or you can have correlated rules be utilized by multiple different standard rules. So that's why you want the names to be the same. You can utilize them over multiple rules. If you are more interested in that, we'll be doing a detection engineering pipeline workshop in March that we're going to get a lot more into detail on that. All right. So
Tyler, before you go on, I think there's a couple questions in the chat for you.
For sure. Thank you. All right. Correlation rules are like a nested concept. Yeah, so correlation rules, you could think of them, as like being nested below it. Like you're going to run the standard rule over here on the left, and then utilizing that information that's in there, we're going to then kind of look almost like you said, like a nested search inside of the log, inside of those values that we get returned back to us, inside of those events that we get returned back to us. If you run just that standard query on the left, like I said, you're going to get if you're at work and have access to a SIEM, look at how many failed logons you've had in the last day or whatever your threshold is. It's like you're going to probably get a lot of pieces back where you really need the context and the correlations to find the bad guy, right? They say that threat hunting is finding a needle in a needle stack, right? It's very difficult, and if you're just looking at tons of logs without any additional context, you're probably not going to find anything. Then Carol says, when we deploy the rule, could those configurations be adjusted? Maybe not 5-minute, maybe 10-minute time span? Yes. Yes, 100%. So the SIGINT rules are just, they're essentially just text documents, right? It's written in YAML, but they're just text documents. So once you get into your rule, you can change the time span to be whatever fits kind of your window, right? Which again gets, I'm not going to get too much into that concept itself in this. That's more of a like I said, that detection engineering pipeline where you have a rule, you deploy your rule, you see how it goes, you do some regression testing or you do some validity testing on it to make sure it hits and it hits in your window itself. So they're definitely going to require, some adjustments per organization or per environment because every environment is different, right? If you have a small company that's 100 people, your failed logon attempts should be pretty low, right? Maybe less than 5% a week, something like that, maybe. But if you're in a huge global organization with millions of users, or somebody forgot their glasses that day, you could have hundreds or thousands of failed logon attempts. You're going to need to adjust that window, right? Are these correlated rules also variable to SIEM-specific detections within converter? If by that you mean if we can change them to be different SIEMs, yes. So that's kind of, again, one of the main benefits of Sigma, instead of maybe just crafting a Splunk query and then putting that out there, is a Splunk query is going to use the group by. That's essentially a stats command, right? You're going to stats values, target username, stats values, target domain name, and that's where you're gonna pull those from. In Elastic or Sentinel or something like that, the command line verbiage or the query verbiage is going to be different, right? So using these correlated rules, you can set these kind of logical parameters one time, and then it can change based off of whatever tool you're utilizing. Is there support for meta variables? You construct something like a risk index score. Also, does detection field support regex? Yes, the detection field does support regex. As far as the meta variables, for something like a risk index score, I am not sure. I'll have to look at that. I'm not sure. That might be something that you add into the query afterwards. I've going off of purely vibes, right? I feel like you probably can, but I don't know 100%. Yeah, and then Noah, thank you for that too. That Sigma allows for some custom fields, but yeah, I'm not. I'd have to test that out. I'm not 100% sure. Thanks everybody for the questions too. By the way, please keep them coming as you have them, and thanks Jared for pointing them out because if I leave the chat window open, I get distracted, so I close it out. All right. And again, I know this is me talking a lot. We got 5 slides left, and then we're getting into the labs. So again, I know that was a ton of stuff. We went over where to get indicators from, where to find the Sigma rules, how to do the standards, a little bit of the detection logic, kind of talking around how to make these rules and pieces like that. But now that we have a rule, right, we're going to take this, not that one. We're going to take that standard rule of the 7-zip, and we're going to convert it, run it in our SIEM, and see if we get any hits back. So my favorite online tool to utilize for conversions is SIG Converter. I believe it is the official repo that utilizes the Sigma CLI. It's essentially a Sigma CLI GUI version, but it's very simple to use. You get your Sigma rule, you paste it on the left, you select your backend, which is going to be your tool. This is a Splunk example. Inside of format or pipeline, you could set different formats, or if this is going to be like a sysmon pipeline or a Windows security events pipeline, and then it'll modify your query a little bit kind of on the fly to fit those parameters. But once you paste it in on the left, it'll automatically translate your rule on the right. So you can see that it took our rule.yaml and turned it into that query looking for the description, image, and command line arguments. And then you can just copy that and toss it into Splunk, and boom, detected, right? We found the bad guy. We did it. So in this example, we see that the 7-zip process is being spawned and used to create a password-protected archive. We can also see in this that this elite hacker person had messed up on the command line syntax a few times, but it still hit on all of these, right? Because we're looking for just contains. We're not looking for a certain order. Excuse me, our rule isn't super specific where changing something very small is going to break it. So even though they ran the argument three different ways, we still got hits on all three of them, right? And we're able to see it here. And you can take this rule, you can change it from Splunk to Elastic or uh, Sentinel, whatever it is, and you'll get the same results, right? You don't have to rewrite it, you don't have to translate it. One piece I do want to hit on this is that Sigma rules don't know what indexes you have, right? Kind of like Noah was saying, and I believe Carol had said also. I believe that you could add in some custom parameters like that, but if you don't, you have just the rules. Sigma doesn't know what index you have; they don't know what source type you have, so you're going to want to specify those in your query. This is more of just like a detection thing, a threat hunting thing. In your SIEM, you have a ton of information, gigabytes, terabytes, ton of information in there. If you don't specify your index or your source type or event ID or pieces like that, it's going to take a long time for these searches to come back. So please don't use index equals star, and please specify your parameters as closely as you can. But that's really as simple as it is to translate a rule, right? You have your rule written, or you find your rule, you throw it in your converter, translate it, copy paste, boom, bad guy found, lunchtime. Alrighty, so did have to talk for a little bit longer than I had intended, so sorry about that. Hopefully it wasn't too much. So now we're going to get into the labs themselves. So to the lab, it took me out of it when my computer turned off. So 1 second, please. And then I have a bunch of links for some additional stuff in the slides that I had meant to copy and paste over, but trying to get through it, I forgot. So I will add those in once we start getting into the lab itself. Do 1 second. Alrighty. So again, everybody, when you hopped on, you should have hit launch group, I believe, over there. It has a timeout after a little bit. That's what mine did, so I had to restart it. If that happens, no big deal. Just hit start, and it'll bring you back into it. Think Trey probably went over this when I was having computer issues. I know you guys had gone through this original introduction. All the familiarization steps are really just there, kind of as a reference. You can just kind of gloss over those or go back to them kind of as you need them. So for this first part, we're going to go through deploying a threat with Scythe, and then all the way through using community created rules. We're going to do both of these sections. What we're going to do in this is hop into Scythe. We're going to do some adversary emulation. Yeah, we're going to do some adversary emulation, do some bad guy stuff. We're going to find some rules that then match it. And then after that, we're going to deploy a campaign that has a lot of different adversarial behaviors in it. And that's where we're going to get more into the nitty gritty. So let's go ahead and run through the deploy a threat with Scythe and then using community created rules. I'll check back in probably about 25 minutes or so. Feel free, if you've gone through that, you can just continue on. This lab environment is going to be up for almost 3 hours. So it's your guys' lab environment to do really whatever you want. If you can go through it pretty quickly, feel free to just continue on. And yeah, so we'll do, take a break, stretch your legs, pieces like that. We'll do about 25 minutes. I'll go over some pieces of it, do a little demo, and then we'll move on to the rest of it. If there's any questions in between, please let us know. Thanks, Ed, and with the really appreciate it. And again, I really appreciate the back and forth you guys have. Sometimes doing these workshops, it's like just talking to myself, and it's lame. So I really appreciate any kind of comments or questions or anything you guys have. Um, yeah, no problem, Daniel. We'll get that to you here in a second. Yeah. One piece two, I don't think I said is the only system you're going to need to utilize through this workshop is going to be that unicorn host down there at the bottom. I know we have the Splunk and domain controller and Scythe image there as well, but you'll be able to reach everything from the unicorn host, so you don't need to interact with the other machines. And another piece too is you guys get into it if you open your Chrome browser. Inside of Chrome is going to be all the bookmarks to reach to reach Splunk or to reach Scythe. If either of those two don't come up after of maybe 5 minutes or so, I would just go back to the systems tab and just restart everything. We had an issue earlier today, like I said, with the boot order of things, like things coming up before the domain controller is up for DNS. So if that does happen to you, it should fix itself in a couple of minutes. But if you go like 5 minutes and you still can't reach it, and it's been up for a little bit, maybe 10 minutes, and it still doesn't come up, then I would just restart everything. And if you have any specific issues, please just let us know. We're able to hop into your environment and see what's going on. Yeah, Brave is great. I use it on my phone. It should like the stuff should come up in anything, but you're gonna lose the bookmarks if you download Brave to get into it. Hey Stacy. Yeah, for that, it's the same thing, whether it's save steps as test or as threat. We recently changed the verbiage we use for the threats and campaigns to test, and I think I probably just have a little bit of an older version in the lab where not everything was updated yet. But yeah, it'll be fine. Alrighty. How is everybody doing? Is everybody onto the using community created rules section? Yes, right. That was a great point out. So this is had this happen the other day too. Um, Oh, look at that. Yeah, found it. So for some reason, I think they must have just gone through an update or something. I'm not sure, but if you click the little gear over here and then change the version to 2.0, it'll start working. So I think that they must have some some kind of an issue or something when the last update that they did. So again, if you get that error that it should say like an error or something went wrong, just click the gear and then change it to 2.0 and then it should work. Okay. Yeah, Ed, for sure. I mean, yeah, take the links in the documentation. Definitely feel free to read through everything. The lab should be, so we've got 2.5 hours. Yeah. So the lab is set up to run for an hour past our workshop time. I don't know why I was having a hard time thinking of the word. So you'll have an additional hour to do stuff. And like I said, this is all really independent time, self-paced. I was just seeing what everyone was doing. I'm going to demo the first part here in a little bit so we can kind of get into the real nitty-gritty of the actual Sigma rules itself. And then MW, no, that is not an Army insignia behind me. That is a modified Eagle Globe and Anchor from a team I used to be on. So we'll give it maybe 2 more minutes or so, and then I'll go over the first part. Don't feel bad if you haven't gotten through it yet or anything. It's just a familiarization. Like I said, I just want to make sure that we can all get into the kind of juicier parts of it. Yeah, thanks, Noah. And then too, like I said, this is your lab environment really. So if you we'll get into in some of the challenge questions or additional time or pieces like that, feel free to run other emulations. The way that we went in and chose the time emulation from or the time procedure emulation piece that we chose from that attack matrix. Like if you have maybe you have some Sigma rules you want to test, or you want to deploy some other um, atomic tests, and then try to find rules for that or write rules for that. Feel free, right? It's kind of the whole point. Feel free to use the platform in any way that you kind of want to, and if you ideally, right, if you did already have some rules using Scythe to kind of push those adversary emulations out, that offensive signal is a great way to test. All right. With that, I'm gonna go ahead and just demo the first piece of this, make sure we're all on the same page here. 1 second. Alrighty. So no, in the first part, it has us go in and create just kind of a you know, getting started emulation, more or less. So we'll go in testing, create test. I don't remember what I say to call it, but you could call it, whatever you would like. You can run Mac, Linux, Windows threats. We're not going to do that for this, just Windows. And then we'll get into loading some of the modules. So we need ARP, we need run, and I believe it's print screen is the other one. Go down to execute an action, show more, has some pre-configured ones. So we want to do, I think it was ARP, print screen, and run who am I? Then scroll back up and go to add attack techniques. I believe it's 1124, system time discovery. So this is what I was talking about. If you had, if you have rules that are meant to hit on different MITRE attack techniques or places like that inside of the MITRE ATT&CK matrix is essentially the all of Atomic Red Team is in here, as well as some custom Scythe ones that we have of some essentially micro emulations. But this will add in all of the steps to do those different attack techniques. So if you have some other ones, like you don't want to do system time discovery, you want to do like DC, I've hit a space, DC sync or something like that, you could just click it and you could, it's pretty simple to go through if you wanted to test some other pieces or run some different emulations. So once those are in there, we'll go ahead and click create test. I know in the lab manual it says to save steps as threat. It's just so you can reuse it. But I'm not going to do that in this example. From here, I've already deployed one, so you just check that box, click download. This will download as a DLL, just to show you kind of a different way to run it. In the next examples, we're going to do it as an exe. It doesn't really matter too much for this workshop either way that you want to do it. And then from that, we will go ahead and download. You might get if this is bad, anything like that. You just accept whatever it says, and then from there, it'll download our downloads directory. We say go ahead and rename the file to dar.dll just so you can copy and paste that run DLL command that we had exactly. If you didn't change the name, no big deal. You can just do run DLL exe or run DLL 32 exe, whatever it was whatever the name was, it was downloaded as, and then comma absolute client main. Absolute client main is a DLL entry point. That's why you have to specify that so it knows where to start. From there, it'll start to run. You can click the little drop down and then Unicorn host for the box we're on. If you want to see the results of what was ran, the request, what was ran, and then the results are down there in that box. And then from here, I know let me go SIG converter first. So in the manual, we have a Sigma rule made by this Pete Zero over here. So you can go to SIG converter, copy paste it onto the left. Again, if you get an error, just click this little gear, change it to 2.0, and then select Splunk, and then your query should just pop up here on the right. And then from that, we'll go over to Splunk. Index equals main. Again, not super important because it's a lab environment, but just good kind of habits to keep up. I changed my time to the last hour. Again, just kind of a habit. And then once you click search, excuse me, you'll see that we get a hit. One thing I do like about this Sigma rule that not all of them have is it will pull out, they utilize the field here, which will tell it which fields you want it to pull out. So if it didn't have that fields here, if I could comment it out. See, if I don't have the fields here, it doesn't have that table on the end. So what this is saying is pull out only the command line value. So if you want to see command line and like image or something like that, so you can see what spawned it. See that CMD spawned it. You can do parent image, which should then be run DLL 32. So it was spawned from run DLL 32. If it was an exe and you just clicked on it, the parent image would be Explorer. Yeah. So was everyone able to get through that? About the fields element Sigma YAML provided in that section. Yes. Sure. Oh, I think maybe yeah. So the fields one here again, it just tells it what fields to pull out of it. Not a ton of Sigma rules use the fields field, which sounds funny. But it is really pretty great. Like pretty much after, like if you didn't have that in there and you did just comment it out and you ran it, you would get, this is only one result. But if it was something, well, you'll see it more when we run the emulation here in a minute. You would just get this raw data back, which is not very easy to search on, right? You're not, like I was saying with the failed logon attempts, if you don't have like this correlation or some kind of grouping in there and you just get 1,000 events, nothing is going to look odd, right? Because it's just too much information. So utilizing the table, or what I really prefer is the stats command, to do like stats, values, command line by image. And then if we had multiple ones, actually try it live. That's not how you spell localhost. Run that command and I rerun this. You should see that. So it still has the same image of cmd.exe, and now we have two different values because I ran it two different ways, right? And if we change it even more to parent image, see that one of them came from PowerShell, the one that I just ran. And you can see that this one was from run DLL 32. Interesting one on this is that here we have three different values, right? But when we switch back to image, we only have, oh no, we still have three. Never mind. Oh no. Yeah, still have three. I misread it originally. But not to get too into just threat hunting. So in that one, so everyone was able to get through that. Okay. Just in our example, again, testing a rule, going into Splunk, see what we have some challenge questions here, just kind of sure everybody is following along. So the next piece is going to be some writing of detections. For this one, we need to start it by, we're going to deploy our threat in the beginning. I'll just kind of show what that looks like here. So again, we'll go into testing, create a test. Sigma, I think is what I want it to be called. Add existing threats. This will have all of the threats, all of the tests, excuse me, all of the tests that we have loaded into our library. If you go down to, if you could just click W, it'll bring you down to Weaponizing Sigma. It'll load all of our steps over here. So this is everything that's going to be ran in this emulation. So kind of another great point of using, you know, Scythe or some kind of adversary emulation tool is to confirm your detections, right? To do regression testing and different pieces like that, tests if your Sigma rules are going to hit, your detections are going to hit, is you can see exactly what's going to be ran over here, right? So kind of the point behind this section is to run this threat. Feel free to look at the exact command line arguments that are being ran and build your Sigma rules, build your detections off that, right? So like here, you could do that your or this one's a good example, that your image is going to be PowerShell, right? Or your parent image is going to be PowerShell, that it's going to have a command line argument of wget. Maybe you could have a command line argument contains AnyDesk, something like that. So by knowing the command that's being ran, it's a lot easier to create your rules. But long-winded way of saying, put this test there, hit create test, check the box, click download. We'll do this one as an exe. Just go ahead and download the file. Wait for it to finish downloading. There we go. Right click, run as admin. Probably even run it as standard user, but right click as admin just to make sure. We don't care about security. And then that'll get that test kicked off. You'll see in this test, like it spawns command line a bunch of times. It opens some windows and browsers. Excuse me. As it opens those, you can just close them out, right? It's just driving that offensive signal forward. So as you're doing stuff, you'll see some stuff pop up. But yeah, once you have that deployed, it's going to run through those actions, and then inside of here on the next step is kind of where it's designed for you to then create your own rules, right? So I give you two examples here of maybe some Sigma rules you could write based off of the actions that we ran in that emulation. So we download a file from the internet via PowerShell. It was actually that example of AnyDesk that I had shown you guys. And there's another one that is a modification of Windows run keys. The Windows run key is an interesting one because, like I was saying in the slides, you could look for process creation with command line arguments. You could look for actual registry modification by different images. So there's different ways you could do it. There's a bunch of different ways that you can detect this activity, right? We have here just kind of a templated example. So you guys really just need to focus on this detection piece, right? I'd say the easiest one to write is a process creation, but the easiest Sigma rule to write is a process creation Sigma rule, because you can just specify something like command line arguments contains, and then what it is, or image contains, or something like that. So I would recommend just starting with that, but completely up to you, right? Um, and then we have a couple examples down here if you need them for some inspiration or you want to, you'll write your own rule later, you want to just kind of convert them now or curate them. Also, if you don't want to write your own rule, you can go to Sigma HQ and start looking through for, PowerShell network connections or registry modifications. Go back to see, I got some calculators spawning over here. You can go back to close edge. There we go. Go back to the emulation itself, see where these are happening. Like, okay, this is using wget. You can search for that now in Sigma HQ to find some rules, right? So if it's not a black box, closed environment. Feel free to use all the resources that you have available here, right? But I would just encourage try to write your own rule. Try to modify a rule a little bit, get a little hands on. Yeah. So with that. Let's and then after that we'll just do correlated detections. And then it's basically on your own. In the bonus, we have some other threats or tests that we think are good for you to deploy and kind of take a look at. But without getting too far ahead of myself, do another 25 minutes or so, see where everybody's at, and then kind of do the same with writing correlated detections, and then just be up to you guys to do whatever you would like. So yeah, again, if anybody has any questions at any time, please feel free to throw it in the chat or any issues come up, or if you have something interesting you found and you want to share, I'd love to hear that too. So do another, like I said, 25 minutes on the timer and then see everybody then. How's everybody doing? Yeah, thanks a lot, Carol. No worries. Appreciate you hopping in. And like you said, the YouTube video will be posted to, or this video will be posted to YouTube probably within the next couple of days. And then the next week or so, you guys should get a copy of all of the slides and then a Sigma, excuse me, a Sigma cheat sheet that we made as well should be coming to your emails, I think probably next week. Hello again, everybody. I'm so sorry that I don't know what is going on with my computer today. Sorry, give me one second to relog into everything. We used to have a ton of issues with our old lab provider, and we switched over to CoreStack, which has been just incredible. But of course, now that we've switched and the lab environment is fine, my computer doesn't want to work. Oh, goodness. Should be able to see it now. Okay, perfect. Sorry about that again. Yeah, so like I was saying, one thing I don't know if this is the right way to kind of start doing it, but this is how I like how I kind of started making them and how I like to do them when you want to see in real time what your rules are going to translate to. Excuse me. Um, so with that, you can go over to Sig Converter and just kind of copy paste this little template we have over here. So here, because like I said, we already kind of have this set up for process creation. We have the command line arguments over here. What you could do is you could just modify these in real time. So like that first example, we wanted downloading a file from the internet via PowerShell. If you were to think, in lieu of having, cyber threat intelligence or logs or whatever it is, just like some different ways somebody might do that. You could change this command line argument to wget. You could have them do invoke web request, different pieces like that. And then if you wanted to get a little more, add some more things in there that maybe, to kind of hone in on your detection here, you could do image. This is the one issue with it is boop, boop, boop. Image ends with, and then you want to give it, PowerShell, something like that. That is so now you can see your rules being translated in real time. You know that what you're putting in there is working. It is YAML, so you do have to deal with, the spaces and the tabs and all the pieces like that. But or if you get a rule from somebody else, like you take this rule here, this example here, you can copy and paste it, and then if there's some little changes you want to make, if this was maybe this is maybe a bad example, contains, and then you want it to be ends with or something like that, you could do it that way. One piece I don't think we hit on this in the slides. I think we talk about it in the manual somewhere. But you have these different modifiers is what they're called. So here, your selection is basically, you're mapping a field to this value, right? So contains is going to put asterisks on either side for Splunk because it's going to put wildcards on either side. So in Splunk, that's asterisks. 1, 2, you have ends with, starts with, reg for uh, regex, different pieces like that. You can look at some of the modifier specification document I sent out in the chat earlier. But a lot of times with image, you'll want it to be ends with because it's just going to add in this piece here at the end. It should actually be PowerShell.exe. Um, so yeah, the image for ends with is just going to be more specific with where it puts the wildcard at, right? So that way you don't get as many results returned that are wrong. So yeah, was anyone able to write their own rule, or you guys just use the examples, or does anyone have one that they want to share? No pressure, just curious. Okay, no worries. If anybody does have one, I would be curious to see what you've came up with. Oh, fantastic. Yeah, having for the registry modification, image ends with command line contains reg. That's fantastic. Yeah, that is a great yeah, that's a great rule. That's awesome. I love too for those who might not see it. I love that you have the command line contains all, so using three different modifiers in there because implicitly, if you don't specify all, it'll just set each of these are just or statements, right? But if you change this contains to all, then you see how that image in or that command line in goes away. Now it has to have both wget and invoke web request inside of the detection. That's a great call out. Thank you a lot, Shrug. Okay, fantastic. And, just kind of keep going on again. SIG converter. This is essentially what your command line arguments, or excuse me, what your query arguments should look like. And then next is, again, didn't want to get super into the correlated detections. It's a little more, not advanced, but it's a little more advanced than kind of what this initial workshop is designed for. We might do a intermediate one or redo this workshop maybe to be a little, have a little more in there. But anyway, so the correlated detections, like we say in here, you can't, and I'll say this, let me verify. Before, you could not take a correlated detection and just copy paste it into one of the online converters. You have to do it through the Sigma CLI. But let me verify that that is still true, because I actually didn't check when I was writing this up. So this is our full rule. Oh, look at that. Now you can do it. You don't even have to install Sigma CLI locally anymore. So that's cool. But essentially, inside of this chapter, of this section of the writing correlation detections, we get a lot more in detail of the different types of correlation detections. We have you go through and install the Sigma CLI because until I guess very recently, you were not able to do the conversions from inside of like SIG converter or anything like that. So you can still feel free to install Sigma CLI. It is still a great reference to be able to do like batch or bulk conversions, or if you have a more advanced user, more advanced detection pipeline, you're going to want to probably utilize Sigma CLI. We'll be going over this in a lot more detail in that class in March, that detection engineering pipeline workshop in March, if you are interested in going. You see it's pretty fast. It'll output it right here into your command line or into your CLI terminal, which is something that I like. I prefer to work out of the terminal. Talks a little bit about why the correlations work. I won't get into this until you guys kind of go through it and then has it convert and then kind of show it off. So I think for this next section, yeah, just go ahead and go through the writing correlation detections. Put probably, like I said, another 15 minutes or so on the clock. We'll kind of talk through this. And then that'll basically be it for the workshop. Again, we have a couple of bonus emulations down here. Each of these have, some kind of hints into things that are happening in there. But if you look at it inside of the Scythe platform, you can see exactly what's happening, and then write your detection logic off of that. Or feel free to use like that attack matrix piece to do some your own custom emulations and different pieces like that. So yeah, give it about 15 minutes or so, see how everyone's doing, and then pretty much be able to wrap it up. Yeah, Noah, to your last point, yeah, the correlated detection rules, being super important. I would completely agree. When I was doing threat hunting at some different organizations or agencies, like if you have a ton of logs, a ton of things being ingested, if you're not correlating it somehow or grouping it somehow or stacking them, you're never gonna find anything. Like you're you're just not. If we had a lot of obviously incident response is done like the incident's already happened, right? You're responding, maybe it's still ongoing, but something has already happened. You have to look backwards to identify things that happen. If you have to look back a month, 3 months in a global organization with thousands of endpoints or tens of thousands of endpoints, if you're just looking for like keyword searches on who am I with no correlated searches, no time span, no things running in a certain amount of time or a user doing something, you're just not going to find anything. And the same, kind of the second point you have over there to reduce alert fatigue and that higher alert accuracy, your alerts should be high fidelity alerts, right? If you get an alert should then spawn an action to happen on your defensive side, right? If you get an alert on something, it should trigger you for a response or at least an investigation into what is happening. If you're getting so many alerts that you if you're getting so many alerts a day that you can't investigate all of them, you have too many alerts. Your alerts are not high enough fidelity, and they shouldn't be alerts. They should just be maybe you're out just proactively threat hunting for something or something like that, or tuning something. But if you get that many alerts in a day where you can't process all of them, or where there's not enough context in your alerts to tip you off to anomalous behavior, you're really just hurting yourself because you're going to stop reacting to the alerts that you get. It's as simple as that. If, yeah, I mean, if you get 100 alerts a day, guess what you're not doing anymore? Looking at alerts. You're just normal, checking the boxes because you're not going to look at all of them. Yeah, it is what it is. Yeah, totally fine to have false negatives and false positives. It's just something that happens. You will have false negatives and false positives. And in my experience, most things you find on a network or an environment when you're threat hunting can be explained. That's why I like to use the term anomalous and not malicious when you first identify things, because right now it's just weird. You don't know for sure that it is malicious. Maybe somebody is using PowerShell to download something from the internet. Maybe a security person. I've done this. I downloaded Mimikatz to an endpoint because we were trying to do some threat emulation in our lab environment to make sure that something was happening. Basically, I mean, almost exactly what we're doing here. But I downloaded it on my work machine and then, had to kind of deal with that. So anomalies does not equal malicious. Just because something is a little weird, it doesn't necessarily mean that it's bad. You need to go through and take a look at it. And then yeah, like Shirag, you said to stack your alerts to that, or to stack and group, or do some tail analysis on your queries to tell that story, right? A single event does not tell the story of what's happening. Most things, like I said, can be explained. Most things are just abnormal or anomalous. You need more context and more information to tell that story exactly like you're saying. Give it a couple more minutes on this. Again, if you guys have questions or anything or something you want to share, please feel free to throw it in the chat. Or if you do want to come on, you have something you want to say, I can promote you and you can say something too. Ed, for the normalization of deviance, Ed asks, is the normalization of deviance something that analysts fall into with these reports? Do you mean like getting different results when you run something? I'm not totally sure what you mean. Or are you talking about the open CTI stuff? Oh, yes, that's a good. So then you said, yeah, so many anomalies happen that people started just assume it's normal. Yes, that is also something to be, I guess, kind of on the flip side of what I was saying before of like having high fidelity alerts or like seeing abnormal things. Sometimes, yeah, when things start, just because something happened once or 10 times doesn't mean that the 11th time it's going to be not malicious or benign or a false positive or something like that. Which again is really just kind of the art of threat hunting, the art of detection and engineering. You know, has some science and some art to it, but that's just kind of um, it's it's again important to have high fidelity alerts for when you do find anomalous behavior that you don't get tired of seeing it, right? What what I mean by that is like if you see a user, some admin, some server admin or something like that that has an administrative PowerShell script that runs with admin rights, scans a bunch of machines and things like that, and it runs every day at a certain time, right? Okay, that's your explanation. That's good. If you see it so many times, you get so accustomed to it, you get like blinders on that. Then if that same admin or if that same admin user runs a different script, maybe a little later at a different time, you might chalk it up to it being the same thing where it is different, where an adversary also identified that the script runs and they're trying to blend in a little bit, or they've just compromised this administrative user or something like that. So while there are anomalies, you'll see trends and things kind of like reoccurring maybe every day or at a consistent kind of heartbeat kind of timeline. It's still important to take a look at them if you're threat hunting. That again is why your alert should be high fidelity, because if you get an alert, you should be investigating it. If it doesn't warrant an investigation, it's not high fidelity, and you should probably adjust it. Yeah, for sure, Noah. That's a great point too. It's like these rules or really anything in infosec or offset. Yeah, I'll just say anything in infosec is not infallible, right? Just because you have this rule that a simple example is like if they use who am I you have a who am I alert or something like that, and you've got it tuned, just right. If you've got, any of these commands run in this certain time frame or anything like that, an attacker can always adjust it. They can run base 64 encoded instead. I mean, there's always kind of ways around it. Nothing is infallible. That's why it's important to always just kind of have that constant threat hunting mindset, right? When you're threat hunting, you are looking for the adversary. You're looking for an adversary that wants to impact your environment in some way. Maybe you work in critical infrastructure, you work at a hospital, you work at somewhere really important like that. You need to keep that threat hunting mindset of someone is trying to impact your organization. Has real world effects. Um, yeah, these detections or queries, logs, tools are not infallible. Alrighty. And then I'm gonna share my screens. Hopefully my computer doesn't restart itself for this last piece. Too funny. Cool. Doing this one, we get into, everybody knows how to read, so I won't kind of go back through all of this. Just want to jump into the rule itself. So yeah, here, this is our standard rule that we're then going to update to make it a correlation rule. It's correlation day. So in here, we're looking for just some living off the land lolbass commands that adversaries run to do host enumeration, right? To do endpoint enumeration. So just some pretty standard ones here. Who am I, Mishta, NetSH, ARP, different pieces like that. This rule, not a great rule, right? Because I have it set to low. These just happen. Single command line arguments are not great detections, right? This is why I thought this was a good rule to kind of make into our correlated rules. So we have our standard rule here. We're going to add in our correlation here at the bottom. So we're looking for, this is going to be an event count of our lolbass discovery rules, right? This is how it correlates between the two of them, how it knows which one to reference. So we want to look at the parent image in a 30-second time span, and if more than three of these command line arguments are ran by that parent image in that time frame, that's an alert, right? So someone running who am I one time could be okay, and an attacker doing some kind of automated scan or something like that. Maybe their playbook is like, hey, well, this is not just like what we think. This is based in CTI reports that we read and observations that we have. When an adversary gets on an endpoint, they want to know where they are, who they are, what they can see, what they can do. It's what they do first, right? It happens every single time. People laugh that who am I is kind of silly. Who runs who am I? Admins, nerds, and adversaries. That's it. Nobody else is doing it. So that's kind of what this rule is designed for, right? To see multiple versions of those or multiple commands being ran inside this 30-second time frame, which again, you can adjust based on your environment, based on what's normal. Maybe you want it to be 5 minutes, whatever it is, right? So this will be our bottom piece here, and then our full rule all the way put together is right here. So then we can go over to SIG converter. We'll paste this rule in there and then go down, and we have our command. So we'll go refresh this, put it in Splunk, see if we get anything. I was working on something else before. Okay, so in here, we're looking at command line arguments of all of these, right, which are just some standard lolbass commands that adversaries can run. We're looking at the time span of 30 seconds, and then again, the grouping is going to be done by the stats. So we want to count how many times it happens by the time and parent image, and then if it happens more than 3 times, we want to know. So in here, we can see exactly what time it happens. We can see that the Sigma Scythe client 64.exe, which is our emulation executable that we downloaded, and it happened 4 times. And then we can also see that cmd.exe is doing it. The reason for that is because inside of the emulation itself, so it runs the that Sigma Scythe executable exe, but for here it is. But then when we have the commands run, we call cmd/c. So that's why it has it in there twice, because it shows it as running from that executable as well as cmd spawning it in its own little shell. But anyway, and two, if you wanted to see what command line arguments they were being ran, you could modify this to command line. You see they ran who am I 3 times, who am I 3 times. So you can still kind of modify these to make them fit your use case. But now you can see in here that this image triggered our rule that they ran this 4 times within 30 seconds. That's something that should be investigated, right? That is a lot more than just running this is just the standard query. So in this, we get 15 hits on all of this, but nothing really bubbles to the top. Like you can add in this again is where that fields where that fields or that grouping really kind of makes sense. Could do stats values, command line by image, and see that, oh, these commands are being ran by these images or by these parent images. Exactly what is being ran, who's doing it. But these still, like, other than we know that the Sigma Scythe client exe is bad because we were looking at it before with that correlated search. But other than that, like CMD running, okay, that's weird. But like these commands being run here in and of themselves being spawned by CMD or being spawned by some different processes like that, not necessarily bad, right? It's weird, but not necessarily bad. Um, yeah. So with that, just again, another reason why you want to be utilizing those correlated searches, so that way you can get the highest fidelity alerts that you could get. Any questions on that? Everybody get something similar to this? Oh, the certificate validation error after installing pip. You can run it with pip install pip. Okay. Oh, thank you, Till. I will have to make a note of that. I didn't get it when I was testing a couple days ago, but I will add that in and fix that. Thank you. Awesome. Did anyone try to make a correlated search or modify a correlated search or correlated Sigma rule in any use? Just curious. I said the correlated rules are pretty new. I think they're only 6 months or maybe a year that they've been out, but they are very powerful and it saves you a lot of time as opposed to having to then do this grouping on your own later, right? It really makes it, I think, a lot easier, even if yeah, that's it. That's all I gotta say. Yeah, with that, then we go. So that is our correlated searches. Do you happen to know if the correlated rules have a counterpart in every major SIEM? They should. So when you go into be able to test it just by doing this, let me refresh this page so I get a full screen. Yes, once you're in here, you should be able to switch it to. Oh, that one does. Okay, so not all. Oh, I think it is two. Okay, maybe it's not pushed out to everybody yet. I said our main one that we use is Splunk. I'm pretty sure it was Splunk and Elastic that, here we go. Elastic has it in there. I think the other ones are being updated, updated kind of as they come in. Like I said, this is still pretty new, so it does not have full conversions for everything with the correlated rules. But if you use Elastic or Splunk, probably the two most common ones, then they do have it in there. Yes, great question, Noah. Thank you. So then, like I said, with that, that pretty much takes us to the end of the workshop. We still have about 90 minutes left of the lab time. So feel free to create your own detection Sigma rules, translate them, deploy different threats, run different emulations, mess around with the Scythe platform. Do those the attack navigator matrix and deploy different TTPs or hunt for Sigma rules or anything like that. The time is yours for the next 90 minutes or so. And then I will stay on here for about, the next 30 minutes or so, right up to 3 o'clock when the workshop is going to end. If anybody has any other questions or comments or conversation or anything like that, be on, like I said, about another 30 minutes or so. Thanks everyone for hopping on. We have workshops pretty much every month at shoot you guys the link. Workshops pretty much every month or Threat Thursday lives that we do. We just talk about adversary stuff. So hope to see everybody over there. Go ahead and end this recording.